It is really nice to have everyone be here today. And in the next 20 minutes, I will present you a technical deep dive and also implementation analysis of the QWen 2.5 VL baseline model. And my name is Shuolin Yin, and you can call me Leo. And here are some like the links for the Hugging Face model and also the GitHub repo if you don't have it yet. And here is a challenge overview of the for 2025 2D task. And I think because Yumu has already go through it, so I won't expand it in here. And and it's same for the task type and also primary evaluation metrics that we have used. Um, and okay, here is a basic model architecture of the QWen 2.5 VL 7B instruct, which I've been using as a base model of the baseline. And it's basically use QWen 2.5 LM decoder as a main decoder, and also it has implemented like additional layer of the vision encoder to implement like the multimodal ability. And if you have any if you guys are interested in of the model, you may just go to their website and check it out. This is a model architecture configuration that I have got for the base model setup. And yeah, so I have using B416 or Flow416 as the fallback and 4-bit quantization with 4-bit NFs and double quantization. And I have set the max context sense to 4K. This is a LoRa fine-tuning configuration that I have got, and you may make some reference to it. And yeah, the target module for the fine-tuning, including two parts. First is it is self-attention components, which include this four, and also the feed-forward layers, which including this three. The training configuration details is that I have using the SFT trainer trainer that is a message from the Hugging Face TRL library. And yeah, I've set the epochs to 3 and learning rate to 1E4 and max sequence length to 4K also. And the image size has been fixed in here into 448 for stable tokenization and also faster training. In this section, I will go through about the data processing pipeline, which is inside the prepared data .py. Here's an overview of how the script has loaded and also validated all the 19 FLARE25 datasets from the prepared data.py. And it will automatically determine the splits that the dataset may have, and also it will validate the image by using the PRL loading and also do integrity checks, and also lastly the format standardization, which ensure consistent structure across the datasets. Oh, and also for QWen 2.5 VL, it has the ability to do the multi-image for a single VQA set. So which we will also enable the multi-image handling in here. And I think it is a dataset format that we have specified for the I think it is for the endoscopic dataset questions. And yeah. Next is a dataset conversion to Hugging Face format. So basically, what I've got is just convert all the training dataset into the Hugging Face format, so it is optimized for training. And yeah. This is the expected output structure if you run the prepared data.py It will output a train validation folder and also a dataset info.json, which shows you the metadata and also statistics of the datasets. In this section, I will talk about the training implementation that has been mainly implemented in the fine-tune QWen2.5-VL. Firstly, I have defined and customized a multimodal data collector in this script because the original predefined data collector function from the SFT trainer library only like it does not support has a multimodal ability, so we have to introduce like our own customized function in here. And I have also implemented like other features, for example, like fast image loading. I'm using CV2 with PIL fallback and also ARAU caching. In memory management with 8 GB default cache size with intelligent eviction, multi-image supporting here, and same for the fixed 448 resolution for stability. And here is how I have the how I have actually implement the image loading also and also the caching strategy. This is mainly the like this is a core code snippets of how I have done it. And it basically achieved like 35% cache hit rate overall in the during the training, and it does has a two times speed improvement by experience. And um, also, I do have set the 8 GB for the memory cache, but you may change the number of this based on your need. And next is the label masking strategies. The core principle of this is that the model can only learn from the system responses, but ignore the user prompt by preventing it to like overfitting from the user queries, but not actually like learn from the responses only. The masking process is that it will identify the system response at the start position and clone the input ID to create a label tensor and tokenize prefix text, mask prefix token with -100 and also the padding tokens with -100. So it can be ignored in loss. Yeah. The for the memory optimization and also error recovery, like I believe like many of you guys may have experienced a OOM error, and it is really common. And the way that in the way I will have tried to I mean like resolve it is just by doing like a error recovery, and in this way that you can set like manually set, for example, a larger batch size at first, and the script will automatically determines what is the match batch size that your GPUs can hold. For example, it will determine if the OOM error has been detected, or if it is, it will automatically reduce the batch size by 2. And yeah. This is a complete command line argument usage. Yeah, this is really comprehensive, and you may adjust many of it based on your need, but it all has default in default with it. And I will introduce best practice at the end of the presentation. In this section, I will introduce a evaluation framework, which is implemented from the evaluate model.py. The overview of the evaluation process is it's first it will done two rounds of the model inference and also evaluation by and also doing a comparison between the two rounds, which was one rounds of base model and also one rounds of the fine-tuned model. And secondly, it will do a task grouping. Certainly, the answer parsing for task-specific output parsing, and which I will tell some more about this later, and also the metric calculations. Lastly, the reporting, it will generate a detailed performance analysis. And additionally, these scripts can also be used to evaluate all or single task type from the scripts. And in the case that you may want to, like, you may have to change your model, or like you may want to do some test. Here's the answer passing by task type, in which is a task-specific response processing. And in this code snippet, I have only shows classification, multi-level classification, detection, and counting because of the page limitation, like the content limitation of the page. And yeah, this is but you may find some pattern between the just in this snippets. For example, for the detection, it will just extract the bounding box of the y min x min y min x my x max y max formats. Yeah, if none of the formats is detected, it will just return nothing. And in this section, I will talk about the inference implementation from the inference.py. In here, I have task-specific inference configurations. Particularly, I do have prompt templates for each specific task. In order to have like a better model response by using some prompt engineering, and also a max token bin set for each for each text based on the need. And next is the task specific parsing functions, which is the same as in the like the evaluation code. And yeah, I'm showing the example of the detection in here. It will be the same, like to extract the x min, y min, x max, y max format. And there are also some full inference usage examples that you might find useful, which is that you can use a base model only by using this command, and or you can use some custom generation settings by setting, for example, you may want to debug it further, but just by setting the verbals, and also no, or like by setting the no quantize. And also you may have you may want to use a train both baseline model just by setting the LAR weights to the model that you want to find. And yeah, the output will be a single file from of the prediction.json file. In order for the challenge submission, like I think you just showed in the showed before. And here is an example that you may refer to for evaluation, but and I will not expand any here. And lastly, which is performance result that has been achieved in this baseline. Um, Overall, it has dramatic improvement at across all the task types, and but it has some base model fails on on all the numerical tasks, like regression and also the counting. And yeah, and lastly, the instance detection is, I think, is the hardest task, hardest task, because yeah, it's only achieving like a F1 score at even at value of 0.3 of 0.042, and also F1 score at value of 0.5 of 0.013, and it is a really hard task for the model to done. Yeah. Oh, and here are some success and also failure examples for for your need to have to provide you like a more better understanding of how we will evaluate the code. Sorry, evaluate the model. For this example, I've shown you like a filter example that the script has failed to parse the model output to the evaluation format. That you can see the model output in here, but the parse output is just nothing. So when it compare with the reference, it will just showing like this is not a successful example. And for this, the same questions. The last one is the output from the base model, but this one is output from the fine-tuned model, which you can see the parse output in here is in the correct format. And if you compare it with the reference or the like the with the ground truth, it will shows it is pretty much closer. And if you calculate it, it should be like within the low E, oh, like, sorry, I mean greater than the low E of 0.5. So this is a success example of the parse format. And lastly, the repository usage and tools, which introduce you firstly the repository structure and also the main scripts. This is a complete code base that I have provided in the GitHub repo. And here it includes all the script you may need and also what it does and what you may have you may use it for. And yeah, the main script are this for the prepared data, fine-tune QWen2.5-VL, evaluate model, and also the inference. To get started, you may need to start with installation and also validation. First, you need to git clone the repository and create a virtual environment, which are pretty basic, and also install the dependencies from the requirement.txt. And lastly, I have also provide and script for test installations for you to test if your uh, core dependencies has been installed correctly installed, and also code availability and model access verification, and lastly the custom module imports has been available in your environment. And furthermore, I do also have a dataset validation file. But if you just directly download the dataset from the Hugging Face from the like the Hugging Face website of our official challenge, you basically I think you won't need to have run this because it should be already like been validated. But it is also a good practice to run it before the training pipeline because yeah, you don't want to have any issue in your data sets. Here and also additionally for more high level control, I have provide or just like an end-to-end pipeline automation that you can just run the run pipeline.sh for a complete pipeline execution by running the bash run pipeline.sh or using chmod. And yeah, and also for this script, you may also use some custom configurations like use subset for testing and max simple of 100 per each task or the number of epochs. Or additionally, you may specify any step-by-step control by doing the like the prepared data only, training only, or evaluate only. And all the parameters that I've showed before are been presetted in this script. And this is what it does inside the script. For example, it first install and also validate the data sets, and they do a data set preparation by running the data prepare.py, and it start the model training, and after the training it will evaluate all the metrics with base model and the fine-tuned model. Basically, it will result in the performance summary of and also the comparisons. Yeah, here's the configuration options you may use, and you may also specify the specific task you want to skip. For example, by skip validation, skip prepare, and so on. Yeah, and here's a usage example of the step-by-step control if you want to run it just singly. For example, the data preparation, if you want to run it for the full data sets, just don't specify anything. Yeah. And if you want to run the subset for testing, just using the usubset parameter. Yeah, and also for training, just you may start the full training by using this three main parameter, or doing some custom configuration that I think I've introduced at the end of the training section. And also the evaluation, that you may evaluate both model for comparison, or you can use a fine-tuned model only just by specify the skip-based model parameter, and lastly the inference. Yeah. And yeah, I think that's conclude but the main part of my presentation. And here are some key achievement and contribution of this baseline implementation. And overall, it has achieved a really high performance on each task compared to the base model. For example, 1,000% improvement on classification task, 26,000% improvement in multi-label classification, or achieved 54% F1 score in detection task, and also lastly 82% green score in report generation. And yeah, I'm happy to take any question you may have right now.
Okay, great. Any questions from the audience?
Hello.
Yeah,
Uh,
go
Yeah.
ahead.
I have a question. So I want to ask, based on what you calculated the scores of regression and multi-label, I think regression and the instance detection, because we don't have samples in validation public uh, set. We don't have samples for the instance detection and regression.
So basically, you can submit your prediction JSON file to the Coda bench, and then you will get the score. And yeah, this is one way, which is the fast way. You can also submit a Docker container to us. We will get back to you the matrix on the hidden validation side.
But I mean that when I clone the repository and try to generate prediction file from my side, then I didn't find any regression and instance detection samples, so I'm not able to evaluate my model. So that what you mean is that when we submit Docker file, then the dataset will be different from the validation public set that we have on Hugging Face? I'm not understanding.
Uh, so are you talking about the hidden validation set evaluation?
Yes, prediction.json file that I generated is incompatible to what you generated. It's different. I don't have any instance detection or regression samples.
It's not mixing. So, I remember we have released the validation, hidden validation images, right? And together with the questions.
Validation hidden also.
Yes,
Uh,
on the
I don't have grounded truth for validation hidden. So how
Yeah,
no,
can
no,
I?
no. Yeah, yeah. This is expected. We won't release the ground truth of hidden validation. You need to submit your prediction on the Coda bench to get the matrix.
So I will not be able to have same prediction.json file from my side unless I submit it on CodeBitch. That's what we
Correct,
say.
correct. We don't release, we won't release hidden validation perform
Mm-hmm.
yet ground truth.
Okay, thank you.
Yeah, thank you. Any other questions? Okay, feel free to post your question in the chat whenever you have. Um, oh, yeah, correct. We will put the recording on the channel website in 24 hours. Okay, and yeah, feel free to post your questions in the chat. And next, let's move on to the last presentation about 3D tasks and the associated baseline. Muhammad, go ahead.